Okay, so we're looking at a preparation video for your first investigation coming up shortly. So you can certainly take a page of notes into the task, so whatever you see you need to summarize it down to one page. Okay, so what we're looking at is starting off with sketching exponential functions. And so we're looking at functions where the variable x is the power. Okay, so rather than having a straight line like y equals 2x plus 3, okay, so for instance, get my pen working. So y equals 2x plus 3. Okay, the variable is not a power, so that's a linear function. So what we're looking at is where the variable is a power, and these are called exponential functions because x is also called the exponent in that position. Okay. So sketching involving, sketching involves creating a table of values and then plotting the points. Then we join the points in a smooth curve using hand, and we don't use a ruler to join the points up unless it's a straight line, which it's not going to be. Okay, so let's look at an example of y equals 2 to the x. So I get a table of values, a few values, minus 2, minus 1, 0, 1, 2. So I've made these values up. Okay, so when, for instance, the first one, 2 to the minus 2, we have a negative power, so we change it to a positive power on the bottom. And 2 squared is 4, so the answer is a quarter. Okay, so negative powers, this is the important thing, negative powers do not give negative numbers, they give fractions. And if you want to, you can just check these answers on your calculator. 2 to the minus 1 is 0.5, 2 to the 0, anything to the power of 0 is 1, 2 to the power of 1, and 2 squared is 4. Okay, so that's where that table of values comes from. So just remember, negative powers do not give negative numbers, they give fractions, because all you're doing is changing it to a positive denominator. Okay, so when we're plotting onto a grid paper, we want to use the whole grid paper to show the features of the curve. And we need to also make the smaller grids nice numbers. So for instance, if 5 grids equals 1 unit, then one grid would be 0.2, sorry. Like for instance, if you have 6 grids equals 1 unit, then that means that one grid will equal 1/6 of a unit. And while that's still mathematically correct, it's a little bit awkward because that would be about 0.17, whereas 0.2 is a nice number because it's a terminating decimal. Okay. So what we do is when we're looking at sketching it, we look at the table of values, and for instance, we're looking at the x values, so we're going to be plotting along the x-axis, and these numbers are symmetrical, so what we're going to do is we can divide them down the middle, so that means you're going to put your y-axis in the middle. Okay, so if these are symmetrical, the y-axis will be in the middle, but when you look at the y numbers, these are all positive, which means that there's no numbers down here, so you're not going to use a bottom part. So when you set it up, okay, so I've got the y-axis goes in the middle, but the x-axis can be at the bottom. Okay, so the x-axis, change colors. So you put the x-axis here because there's no negative numbers, so you can use all the positive values. So look at the values before deciding what your axis is going to be. Okay. Okay, so I've got a set of grids, and again, I didn't put the x-axis right down the bottom of the page, but you could have. And then I've gone 5 grids across, 1, 2, 3, 4, 5, and then put a 1, and then a 2, minus 1, minus 2. But I couldn't use 5 grids up and down, I just didn't have enough space, so I used 4 grids for 1. So on the vertical axis, each grid is worth a 0.25, but on the horizontal axis, each grid is 0.2. So that's going to be useful. So then when we plot the points, okay, I'll change it to a red. Okay, so for instance, 2 to the 0 was 1, 2 to the 1 is 2, 2 squared is 4, so there's my 3 pots there. 2 to the minus 1, so these are 0.5, so a half will be there, and a quarter will be there. So I've done my points, and then the next skill is to join them in a smooth line. And now this is hard on a vertical board, but when you're doing it on your paper, hopefully you'll get it right. And again, you do this in pencil, and just make sure you try to do a smooth curve. And the line extends to infinity both directions. So you try to make it as smooth as possible, because for the next part of in the investigation, you have to have a smooth curve. Okay, so that's how you draw the curve. Okay, so let's look across the next page. So what I'm doing now is, because this is actually a calculus investigation, we're looking at tangents, okay? So what I'm doing is, for instance, I'm doing a tangent at x equals 1, okay? And just remember that a gradient is the change in y over the change in x. And by using, like I could do it at any point, but I'm using x equals 1, okay? Because then the change in y, you can see is the difference between 2 and 0. So the change in y is a nice number. Now to get the change in x, what we're going to do is we're going to use the x-intercept. Okay, so we draw our tangent with a ruler, okay, so you have to use a ruler. Okay, and then we draw our tangent so it just touches the curve, and then it intercepts, so that's the x-intercept. Okay, and then because we can now look at the x-intercept and this x value 1, we can just count how many grids we've got, and there were 7 grids and each grid was 0.2, so our change in x is 1.4. So the approximate, because it's just a ruler on a sketch, the approximate gradient is the change in y over the change in x, and it's about 1.4. Okay, so we're using the x-intercept across to the x value to get the change in x. Okay. Okay, so now we're going to connect it with the calculus, which is an instantaneous rate of change. And from last year's calculus, the instantaneous rate of change is the value of the gradient of the tangent, okay, at a particular point. So when I go back to this one here, okay, the instantaneous gradient is not necessarily going to be 1.4. It may be 1.4, but this is an approximate method. But we're trying to find the exact change, or the exact gradient at x equals 1, or x equals 2, or x equals minus 1, whatever. Okay. So, the gradient by first principles, and we're not going to go back to first principles, but we need to use this definition. Okay, so the value of the gradient is the limit as h approaches 0 of fx plus h minus fx over h. So, what we've got is our x value, and then we've got x plus h, and this is, okay, so that we're trying to make this value of h, the difference between along the bottom, as small as possible. Now, before we found the shortcuts, we used to do a table of values, and we made h really small, and for the point of this exercise, we're going to make h equal to 0.01. Okay, so that's a really small change, but from x, we're going to go a small difference forward and a small difference backwards. Okay, let's move across. And, sorry. Now, because we haven't done exponential derivatives, we're just going to start with a normal function. So if y equals x squared, and I'm going to find the gradient at x equals 2, I'm going to use the shortcut. Okay? So if y equals x squared, the derivative is 2x. You should be able to remember how to do that. And then at x equals 2, the gradient is 4. Okay? So that's the exact value. Okay? Now what we're going to do is use the table of values and show that we can get pretty much close to 4. So what we've got is a little bit above 2 and a little bit below 2. Okay. And I'm just going to pause and get my calculator because I forgot my calculator again. Okay, you probably didn't even know, so I was gone, but I went and got my calculator. So we're going to do, okay, so the function is y equals x squared. So 2 squared's 4. And then 2.001 squared, and we have to write all the decimal places in, 0.04001, and 1.999 squared is 3.99601 as well. Okay, so the gradient is the difference between the values, so the change in y between those two values is 0.04001, and the difference between those numbers is 0.001, and then when you do that on your calculator you get 4.001, which is pretty close to 4. And let's see what happens on the other side. Okay, so the difference between those numbers is going to be 0.00399, and we've got 0.001 again, so we've got 3.999, And so if you have a look at the values, we've got 4.001, 3.999. So we're squeezing the value 4 in between them. So using h equals a really small number, we're getting a close value to the instantaneous gradient, which is exactly 4. And if we went smaller and smaller, we'll get closer and closer to 4, squeezing from both sides. Okay, so that's how you do it with the table of values. Really small above, really small below, and then just do a change in y over a change in x, and then you'll squeeze the value in between the two. Okay, so let's move across. Okay, so the last couple of slides is just talking about errors. Okay, so when you do it by hand and when you do it by table, you can have a difference, and we're going to look at percentage errors. So when calculating a percentage error, okay, we divide the difference between the numbers by the original score. Now the original score will be the exact value, okay, and then to change a percentage to a fraction to percentage, we multiply by 100. So for instance, in that previous one, okay, the difference is 0.001 between those two numbers, and then we would divide by 4, and then we get our percentage error. Okay, so we divide by the original score, the exact score. Okay, so let's have a look at an example. We're nearly finished. So if you got a value of 3 and the value should have been 2.5, okay, that's what it should have been. So the difference is 0.5 between those two numbers, and we divide by what it should be, and then times it by 100. So we have a 20% error. Okay, so you can take one page of notes into the task. You decide what you're going to take in, and all the other information will be on the task. Good luck.